In this video, we'll discuss a few more examples on how do we find the duality of some function using the fundamental theorem of calculus, part one of that. Okay, so what's part of that? Part one of that. So if you have f here is continuous on the interval a, b. Now, for any x between a and b, we define g of x to be integration from a to x f of t dt, right? So the fundamental theorem of calculus part one here says then g prime equal to f, right? G prime of x equal to f of x, right? So basically d over dx integration from a to x f of t dt is f of x. So this is basically one way to figure out the antiduality of a given function, right? Okay, so let's see a couple examples. The first one here is our function f of x is integration from x to 0 square root 1 plus secant of t dt, right? We want to find f prime of x. Now, how do we do that? We want to apply fundamental theorem of calculus. But here in our result, x is on top, but here x in the bottom, we can switch it, right? F of x equal to negative. If you switch the upper bound, lower bound, you put a negative in front of the integral, right? Then by FTC part one, right? By FTC part one, f prime of x equal to negative, replace t by x, square root 1 plus secant of x, right? This is basically the derivative of this function. Now let's see our second example. Second example is what? Is we have a function g of x, which is integration 0 to 0 to okay, natural log of x tangent of x squared dx, tangent of t squared dt, sorry. So we need to change the variable name to avoid confusion, right? The dummy variable, you can change anything you want. So we want to avoid use the same letter as the variable of g, right? So we want to find g prime of x. Now, how do we do that? Okay, so now you can see that the fundamental theorem of calculus, the upper bound is a single variable x. This is another function, right? The variable name doesn't matter. You can use x or any other letters, but you have to apply fundamental theorem calculus to integral. Upper bound is a single variable, right? You can use, you can replace x to be y or u or anything you want. So we just try to understand this function better. So this function is basically a composition of two functions. Outer function is this integral function. Inner function is natural log of x, right? So basically, that we should use chain rule to differentiate this function, right? So let's try to make our chain rule easier to understand. So let's give a name for our inner function. So let u equal to natural log of x, right? You can see that in this case, u prime of x equal to 1 of x. And give a new function for the outer function, k of u is integration from 0 to u tangent of t dt, right? Now from here, k prime of u by the fundamental theorem of calculus part 1. So this is tangent of u, right? So now we know that g of x is k of natural log of x. So g prime of x is what? K prime of natural log of x times natural log of x prime by chain rule. So this is equal to what? This is equal to tangent of natural log of x, because k prime tangent, right, times 1/x. So that is the duality of this function here. And so let's write down a general formula for this, right? Remark: if g of x equal to integration from a to h of x f of t dt, then g prime of x, for sure, we are assuming all the functions are continuous and differentiable, right? G prime of x is f of h of x times h prime of x, so that you can apply the fundamental theorem of calculus part 1 and also chain rule to get it, because this g is a combination of two functions. We can differentiate both of them.